Nobody told you the solar system had an edge. Not really, not in a way that landed. They put up the poster in your classroom. The one with all 8 planets lined up in a neat row, evenly spaced, Sun on the left, Saturn with its rings, everything clean and comprehensible and contained, and it gave you the deeply false impression that you understood the scale of where you live, that the solar system was a neighborhood, that the planets were a family, that space, while large, was the kind of large that could be framed on a wall. But there is a place 2.8 billion miles from the sun where everything you think you know about our solar system starts to come apart, where the light from home has already faded to something 30 times dimmer than what you feel on Earth, where the wind moves faster than any wind in the solar system, faster than fighter jets, faster than anything your body has a reference for, and where the planet itself radiates a grief into space that scientists still cannot fully explain. Beyond it lies something we did not predict, could barely map, and still don't entirely understand. And beyond that, nothing, or something. We're not completely sure which is worse. Neptune is the most beautiful planet in the solar system, and nobody talks about it enough. It is the color of a deep ocean dream, a blue so saturated, so vivid, so electrically alive that it looks like something a painter invented rather than something physics produced. Not the pale, washed-out blue of Uranus, not the banded ochre of Jupiter or the cream and gold of Saturn. Neptune is the blue of the deepest trench in the Pacific, of a sky 10 minutes after sunset when the color is almost too intense to be real, and it sits at the edge of the solar system like a jewel someone left there deliberately, glowing in the dark at a distance so remote that the sun from Neptune's surface is just the brightest star in a sky full of stars. Voyager 2 flew past Neptune in August 1989. It is still the only spacecraft to have done so. The images it sent back electrified the science community. A planet more dynamic, more atmospheric, more visually striking than anyone had predicted. A great dark storm system, dubbed the Great Dark Spot, churning at its equator with the proportions of Jupiter's Great Red Spot, clouds of methane ice streaming across the blue, a moon, Triton, orbiting backwards, geysers erupting from its surface, nitrogen plumes rising kilometers into the thin air of the most distant large moon we had ever seen up close. It was extraordinary. It was magnificent. The images looked like something from the opening frames of a science fiction film. The planet the protagonist sees through the window just before everything goes wrong. And then you start to look at the numbers, and everything goes wrong. Neptune is the windiest place in the solar system. Let that breathe for a moment, because Jupiter exists and Saturn exists, and both of those planets have weather systems that dwarf entire worlds. And Neptune, smaller than both, colder than both, receiving a fraction of the solar energy that drives weather on those giants, is windier than all of them. Wind speeds on Neptune reach 1,500 miles per hour. Not gusts. Sustained, directional, planet-encircling winds that move at nearly twice the speed of sound on Earth. The fastest wind ever recorded in Earth's atmosphere. During a typhoon, at altitude, measured by instruments specifically designed to capture extreme conditions, and was around 250 miles per hour. Neptune's baseline wind is 6 times that. Neptune's baseline wind is fast enough to cover the distance between New York and Los Angeles in 2 hours. If you were somehow suspended in Neptune's upper atmosphere, not on a surface because Neptune has no surface, just layers of atmosphere growing progressively denser and hotter until something beneath them might, theoretically, be called solid, the wind would not push you. It would not knock you down. It would unmake you. It would strip material from your suit before any other danger had time to introduce itself. Your body, relative to 1,500 mile-per-hour wind, is not an obstacle. It is a momentary disruption in the airflow, a brief turbulence, and then it is past you, and you are gone. But here's the problem. Neptune's winds aren't caused by the sun. They're barely affected by the sun at all, and the source of the energy driving them is one of the strangest unsolved mysteries. In planetary science, Neptune receives 900 times less sunlight than Earth. 900 times. The sun from Neptune delivers so little heat that it should be inert, frozen, a dead, still, cold ball of ice and gas at the edge of the solar system, barely disturbed by the star it orbits. There is no reason that our current understanding of planetary physics can fully satisfy, for Neptune to have the dynamic, violent, energetic atmosphere it has. And yet, it radiates 2.6 times more energy than it receives from the sun. Neptune is generating its own heat from somewhere deep inside, and that internal heat is the engine driving the most violent winds in the solar system. Something in Neptune's interior Perhaps the slow gravitational settling of its mass, perhaps exotic chemical reactions we don't yet have models for, perhaps something about the behavior of matter under pressures we cannot replicate in a laboratory is burning, slowly, continuously, and the product of that. Burning is 1,500 mile-per-hour wind and a blue jewel glowing at the edge of darkness. We sent Voyager 2 past Neptune for 12 hours. 12 hours of flyby data is all we have ever had, all we have ever gotten from the most distant planet in the solar system. 12 hours of measurements, and then Voyager 2 continued on its way, heading south out of the solar system, and Neptune has been essentially unstudied up close ever since. We know it has an internal heat source. We don't know why. We know it has winds we can't explain. We don't know the mechanism. We know it has a magnetic field tilted at a bizarre angle. 47 degrees off its rotational axis, offset from the planet's center by more than half its radius, producing a magnetic environment so chaotic that compasses on Neptune would be useless even if you could survive long enough to hold one. But it gets worse. Triton is wrong. The moment scientists calculated its orbit, something in the data didn't fit the expected pattern, and the wrongness of it has been sitting in planetary science like a splinter ever since. Triton orbits Neptune backwards. Every other large moon in the solar system orbits its planet in the same direction the planet rotates, a gravitational inheritance from the disk of material they all formed from. Triton orbits in the opposite direction. This is not a quirk. This is a declaration. Triton was not born here. It was captured, a wandering body from the outer solar system, caught by Neptune's. Gravity at some point in the distant past pulled into orbit, its original path bent and locked into this retrograde loop from which it will never escape, and it is spiraling inward, slowly by geological standards, but inevitably. The same tidal forces that make Triton geologically active, that power the nitrogen geysers erupting from its surface, that keep the interior warm enough to possibly maintain a subsurface liquid layer, are also draining orbital energy from Triton's path. In approximately 3.6 billion years, Triton will cross the Roche limit, the distance at which Neptune's tidal forces overcome the Moon's own gravity, and it will be torn apart, ring by ring, fragment by fragment, a moon the size of a small planet dismantled by the gravity of the world it was never supposed to orbit, spread across the sky in a ring system that will make Saturn's look modest. Triton is a moon living on borrowed time, orbiting a planet it doesn't belong to, falling toward a destruction written in physics from the moment it was captured. And right now, it is the last landmark, the last moon of the last planet. Beyond it, the solar system's map starts to blur. And this is where things change. Cross Neptune's orbit, and you don't enter emptiness. You enter the Kuiper Belt, a vast, diffuse halo of frozen objects, billions of them, stretching from Neptune's orbit to roughly 50 times the Earth-Sun distance. Dwarf planets drift through it. Pluto, Eris, Makemake, Haumea. Objects we have named and some we have cataloged and most we haven't found yet. Ice and rock and methane and ammonia, frozen solid, moving in slow ellipses so wide that a single orbit takes hundreds of years to complete. The New Horizons spacecraft flew through the Kuiper Belt in 2015, past Pluto, past the object we named Arakoth, a contact binary that looks like a cosmic snowman, two ancient planetesimals gently touching, relic material from the formation of the solar system so pristine and unchanged that scientists described it as a time capsule from 4.6 billion years ago. Everything we are made of, everything that eventually became Earth and the Moon and every living thing, was once material exactly like Arakoth, floating, cold, undisturbed, waiting. But here's the problem. The Kuiper Belt ends, and what comes after it is not an edge. It's an abyss. Between the outer Kuiper Belt and the Oort cloud, the vast spherical shell of cometary material that represents the true gravitational frontier of the Sun, there is a region called the scattered disk, and beyond that, a gap, a wide, largely empty band of space where the Sun's influence is real but faint, where objects exist but are sparse, where the solar wind thins toward the heliopause Voyager crossed in 2012. This is the zone where the solar system dissolves, not with a wall, not with a line, but with a gradual, terrible fading, like the signal on an old radio losing stations one by one as you drive away. From the city until there is nothing left but static, But that's not even the worst part. The Oort cloud has never been directly observed. We have never sent anything there. We cannot image it. We infer its existence from the long-period comets that fall inward toward the sun. Objects with orbits so elongated that they take thousands of years to complete a single loop, arriving in the inner solar system as bright visitors from a distance almost incomprehensible in its remoteness. When those comets come from, when we trace their trajectories backward to their origin points, the math points to a spherical shell of icy bodies surrounding the solar system at distances between 2,000 and 100,000 times the Earth-Sun distance. 100,000 times. The Earth-Sun distance is 93 million miles. Multiply that by 100,000. Let the number exist in your mind for a moment and feel how it doesn't fit there, how your brain reaches for a frame of reference and finds none. The outer Oort cloud is thought to contain trillions of objects, the source of all long-period comets, a vast reservoir of material left over from the formation of the solar system, loosely bound, barely held by the sun's gravity, occasionally disturbed by passing stars or the gravitational tide of the galaxy itself. A single stellar encounter, a star passing within a light year or two, which happens on astronomical timescales, can dislodge thousands of Oort cloud objects at once, sending them cascading inward. A rain of comets, triggered not by anything in our solar system, but by the slow, indifferent movement of the galaxy around us. There is a hypothesis, contested, taken seriously by some astronomers, not yet confirmed or disproved, that mass extinction events on Earth may correlate with exactly this mechanism. The galaxy rotating, stars passing, the Oort cloud disturbed, comets falling, the dinosaurs looking up at a sky they did not understand, encountering the downstream consequence of a stellar passage that happened millions of years before they existed, the universe rearranging things on timescales that make civilization look like a blink, and sending the debris inward like a slow, long-fused message. We live inside that system. We have always lived inside it. We just didn't know, for most of our history, that the sky had a mechanism. There is a specific grief that comes from understanding scale. Not the grief of loss, the grief of proportion. The grief of standing at the edge of something so vast that your presence within it is not even a rounding error. Neptune is the last full stop in a sentence that took 8 planets to write, and beyond it, the sentence doesn't end. It just keeps going. Kuiper Belt, scattered disk, heliopause, Oort cloud, the vast interstellar medium between us and the next star, and beyond that 400 billion more stars in this galaxy alone, and beyond that 2 trillion more galaxies, and beyond that a universe whose true extent we may never, even in principle, be capable of measuring. We drew the poster. We named the planets. We lined them up on the wall and put the sun on the left and called it the solar system and convinced ourselves we were oriented, that we had a home we understood. But the classroom poster ends at Neptune. And Neptune, it turns out, is not the last word. It's barely the first sentence of the last paragraph of a document we haven't finished discovering. Voyager 2 passed Neptune in 1989, spent 12 hours gathering it, the only close-up data we have of the most distant planet, and then kept going. It is still going now, out through the Kuiper Belt, toward the heliopause, into interstellar space, on a trajectory that will carry it through the galaxy for billions of years without stopping. We know where it is because we can still hear it. Barely. A signal at the edge of detection, a whisper from a machine older than the internet, telling us it is still out there and still moving. What it is moving through, we are only beginning to understand, and what lies beyond the Oort cloud, the true outer boundary of our sun's influence, the place where the sun finally loses its gravitational claim and the galaxy begins, is a region no human instrument has ever reached, in a universe we have been observing for a few hundred years with equipment we invented last Tuesday in cosmic time. On a planet that formed at the edge of a galaxy that formed 13.6 billion years ago for reasons that remain, even now, the subject of our most fundamental and unanswered questions. Neptune feels like the end of space because it is the last thing on the map, but the map, it turns out, is almost entirely blank. We drew it as far as we could see. We named what we found. We sent machines into the dark with golden records and scientific instruments and the stubborn, specifically human conviction that understanding where we are is worth the extraordinary effort of looking. But the universe did not shrink to fit our understanding of it. It never has. Every time we extended the map, there was more beyond it. Every time we reached the edge moved. Every time we thought we understood the scale of things, the scale grew. Neptune glows blue at the edge of our knowledge. beautiful and violent and half understood, and beyond it, the darkness doesn't end. It just becomes the kind of dark that doesn't have a name yet.